Yeah, warm good afternoon class. In the previous video, we have seen two types of heat treatment. One is hardening, another one is normalizing. So as a refreshing of it, normalizing, as usual, heating, holding and cooling takes place in the normal still air. Okay. In the hardening process, again it's the heating, holding and the cooling takes place very rapidly, means that we are going to dip the or immerse the particular piece which is to be hardened. After holding process, we have to dip or soak it or dip it or immerse in the running water or cold water or brine solution in order to achieve the martensite microstructure. So this martensite, achieving this martensite microstructure is more important, which because this martensite microstructure is just the highest hardness. So if you want a particle, if you want a certain specimen to be hardened, so we are going to harden. We are using hardening process where the production martensite formation is predominant. Okay. So next process and last process, tempering process, right? Here the tempering process, as I like to mention here, is that we will not use hardening process as like that. So means that if we are going to do hardening process, then we will do tempering process as well, because a workpiece or a material which is highly hardened cannot be used for many applications, right? See, if for example, if we take a material which is very hard, so means that means applying any stress, it cannot expand. Okay, it cannot be expanded. So if a material cannot be if a material upon hot working or cold working or mechanical work or thermal work, it should be expanded. Okay, for a little while. So if it is not expanded at the time, then the material will get broken. For example, if we take glass is highly hard, it's very hard material. So if you apply any force, it cannot expand, so it is get easily broken. Like that, here in a tempering process, here my martensite which is formed due to hardening process cannot be used. So or we can say the workpiece which is completely martensite cannot be used for any application, for most of the applications in an engineering world. So we have to convert this martensite in another format which is known as tempered martensite, where by achieving this tempered martensite, we can improve ductility and toughness. Moreover, we can reduce the hardness. Means that we are not drastically reducing the hardness, but here upon doing this tempering process, this hardness we can say from 100% hardness, it is drastically, or it is moving down to 70%. So at the same time, decreasing of this hardness, at the same time there is improvement of ductility and toughness, where the particular material gets ductility, toughness and hardness, where these three properties can be achieved by using this tempering process, right? So hardness to a certain to the desired limit. More with that hardness, we are having more ductility and toughness. So this martensite, upon forming convert to tempered martensite, will have both strength, ductility and toughness. So as usual, here the main objective is that to remove the internal stress, impart wear resistance, reduce hardness, not to remove hardness, to reduce hardness and improve ductility and toughness. So this martensite is formed, use this type of tempered martensite is formed using this tempering process. So here you can see the material is heated to a temperature. This line is a 730 degrees Celsius line, so it is heated about 800 degrees Celsius, where here you can see there is a sudden cooling process. There is not slow cooling, here it is a sudden cooling process. Here is a sudden cooling process. This sudden cooling process helps to form the martensite, right? So helps to form the martensite. So this helps to form the martensite. From this 800 degrees Celsius, there is a sudden falling of temperature to around 200 or 100 degrees Celsius to form the martensite. So here where the transformation takes place, right? From austenite to martensite. So as I already said, this martensite cannot be used as the used on many applications. Then we are going to use the tempering step. This is the this is the continuous step which is known as tempering process, where this martensite contains the contain specimen or workpiece is again heated up to a temperature around 400 degrees Celsius, and again it is rapidly cooled. This martensite is now it is forming tempered martensite. So this martensite has only hardness only have high hardness, but this tempered martensite have high hardness, ductility and toughness. So importing these type of these mechanical properties, it can be used for a wide range of applications. Okay, thank you. We'll see the two types of tempering process in the next video.